2 microcoulomb charge lie on the straight line between 3 microcoulomb charge and 1 microcoulomb charge. Separation 3 and 1 microcoulomb is 4 cm. Number 1, draw the position of the 3 charge and show the force X on the charge negative 2. So this is a charge, right? You see this is a charge negative 2 microcoulombs, and in between charge 3 microcoulombs, this is positive 3 microcoulomb, and the charge 1 microcoulomb, and the distance between the 3 and 1 microcoulomb here is equal to, this is equal to 4 cm. So the force, the force X on the negative 2 coulomb. So meaning the force by the charge 3 coulomb on the charge negative 2. So what happened to the charge negative 2? Because this is negative, so the force by the charge 3 microcoulomb on the charge 2 microcoulomb direction to the left, and the force by the charge 1 microcoulomb on the charge negative 2 microcoulomb. So what happened to the negative charge negative 2? Because this is negative, so meaning the direction of the force is to the charge 1 microcoulomb, because this is positive and this is positive charge. Number B, calculate the distance of 3 microcoulomb from the negative charge 2 microcoulomb, right? So meaning this is a charge 3 microcoulomb, and this is charge this is positive, right? This is positive, and this is a negative 2 microcoulomb, and this is a charge 1 microcoulombs. So the distance 3 to 1 microcoulomb is 4 cm. Let's say this is a distance x. So the distance between the charge 2 negative 2 microcoulomb to 1 microcoulomb is a 4 minus, the distance here is 4 minus x. So the question is to calculate the value of x. So you can use the force between charge 3 to negative 2 and the force 1 onto the negative 2. So the equation for the force between the two charges given by the kq1 q2 over r square. But net force on the charge negative 2 is equal to 0. So meaning the total force by the F charge 3 to the charge 2 to the left, and the force charge 1 on the charge 2 to the right is equal to 0. So meaning the force 32 is equal to force, so the force 32 is equal to force 1 2, because of the net force on the negative 2 microcoulomb is equal to 0. So meaning the force to the left is equal to force to the right. So this is calculation. So F32 is a K, Q3 is a 3 microcoulomb, and 2 is just this is just the second charge is a 2. No need to use the negative sign, just put in the magnitude is 2 microcoulomb. Sorry, this is 2 microcoulomb, and divided by the distance here is a x, and this is equal to force charge 1 on the charge 2, this is k, and the charge 1 is a 1 microcoulomb times charge 2 is a 2 microcoulomb, and divided by the distance between charge 1 and negative 2 is a 4 minus x. So 4 minus x. So you can use the calculations here to find the value of x. So this is k answer, right? So the final answer for the x is equal to 2.54 exponent minus 2 meter. Thank you.